Okay, as for the second question of our homework, we like to make a summary of all of those characteristics of those stochastic processes, and summarize their definition and summarize their properties. We take a first look. First, we look at this wide sense stationary, and as for its definition, it's very easy. It's the expectation of the expectation of the stochastic processes is a constant, and the autocorrelation function is a function of the difference of the two difference of the time. As for some properties, we know that y-side stationary does not usually lead to strict sense stationary, but given that given the condition that we're talking about a normal process, it leads to a strict sense stationary. The second is the independent increment, which means that any two timeline T1 and T2, the difference of these stochastic the difference of the two random variables are independent, mutually independent, which means for non-overlapping T1, T2, T3, T4, we have the probability of the product equals the product of the probability. So independent increments always implies the uncorrelated increments. Uncorrelated increments, which means the expectation value of the product. The mean value of the product equals the product of the mean value. Okay, as for the third one, the Markov processes, which means that the distribution, the random variable is gonna take in the next moment is only decided by the distribution by the distribution of the random variable at this moment, and not at this past behavior, which means that this conditional probability equals to this conditional probability. You see that from T3 to the Tn, its past behavior is omitted. As for this normal process, which means that for any n and any T1 minus for any many amount of time, the a normal distribution function, it's joint normal. So combined with as for this property, combined with the WSS, it could lead to SS, which have been mentioned before. Okay, so we're gonna move on to the last three processes.